Another method, instead of using a laser, is to use a very, very bright fluorescent lamp. A very bright fluorescent lamp. And what I'm meaning here is a runway landing lamp. Safety-wise, what you have to bear in mind is two things. Firstly, the flue gas analyzer is halfway up the chimney. Secondly, these lamps, either the laser or the runway landing light, are very, very bright lights. You have to be careful not to look at the source directly. Normally the bright light is kept inside what's called a dark box, which only allows infrared through. But it is possible to open the box and look at the light. If you do that, you will be blind. It will blind you. Now, granted, it will only blind you for half a day, but you do not want to be blind when you're halfway up a chimney stack, because you can't get back down. And before you know it, you're hanging on your safety harness and everybody underneath you is getting a shower because you've had a bit of a fright. So it's very important that you bear in mind that these things have got bright light sources. The bright light source is very dangerous to your eyes and is doubly dangerous because of where you are. One thing that we have a problem with infrared sensors, infrared light sources, is that there's plenty of other infrared sources around. The sun is at the top of the chimney, and normally there's a boiler at the bottom of the chimney. Both of these are infrared sources. So to tune out those other infrared sources, we use a thing called a chopper wheel. A chopper wheel is a wheel with holes in it, with a motor that spins that chopper wheel very fast. That way, the light that arrives at the sensors is only at one particular frequency, if you like. It's been chopped, it's been modulated. Now, as far as call-outs to this thing goes, what do you think are going to be your call-out items to this type of sensor? You are absolutely right. I forgot about the dust. Basically, when anybody that's had anything to do with a chimney stack knows that it's full of dust. One of the main things you'll have attached to you, when you go up this chimney, you'll have your safety harness on. One of the things you'll have carabined to the back of your safety harness will be one of those little portable vacuum cleaners, because the dust gets everywhere. The dust is terrible, so you have to go up there and vacuum it out regularly. The globe blows. It's a globe, and it blows. So that's one of the big call-out items. The next big call-out item is the chopper wheel. The chopper wheel is driven by a little electric motor. The little electric motor burns out. There's a lot of call-outs on these things. When they work, they're great, but there's a lot of call-outs to keep them working. We can either look at just one frequency, or we can look at several frequencies. Here's a drawing of a different type of one, just slightly different, and it's got the chopper wheel assembly and the motor assembly, the infrared source, and what it's using is a mirror. So it's shining the light in, reflecting off the mirror, and bringing the light back. This thing would need vacuuming out regularly. Probably it'd need the mirror cleaning. Now be careful when you clean these mirrors. You can actually clean the entire mirroring off the mirrors, and then it kind of stops working. There is yet another method which uses an even cleverer chopper wheel. And this chopper wheel, because the outside of a wheel spins faster than the inside of a wheel, it chops the infrared into frequencies which are near the acoustic frequencies, which are sound waves. And then what happens is we measure the different frequencies coming back. And from the different frequencies coming back off the chopper wheel, we can tell whether there's oxygen or carbon dioxide or nitrous oxide inside the gas. And so this system with a clever chopper wheel, once again, this can actually tell you whether there are lots of different gases in. Still the same problems though. We have got a globe that's going to burn. We've got a chopper wheel which is going to stop rotating. And basically the whole thing will fill up with dust. And on top of all of that, it's halfway up a chimney stack, which is not the best place to be. And as you know, as with all things, it will break down in the middle of the night, in the middle of a storm. In addition to measuring gas quality going through chimney stacks, it's also becoming increasingly important to measure something which is called air quality. Air quality is kind of a measure of how polluted something is. What they discovered in a lot of places is that some buildings where we constantly recycle the air quality drops off, and people were getting an illness which they called sick building syndrome. Air quality consists of lots of things that cause pollution. There's carbon monoxide, nitrous oxide, ozone, and sulfur dioxide. I just look at those in order. The first one, carbon monoxide. Carbon monoxide is a particularly dangerous gas. Carbon monoxide is formed by the incomplete combustion of carbon. Basically, if you look at a flame, if a flame is burning yellow, what you're doing is you're taking carbon and oxygen, combining them to make carbon monoxide. It's not a particularly hot flame because you've got incomplete combustion. If, on the other hand, you combine carbon and 2 oxygens, then you make carbon dioxide, and you have a blue flame. The blue flame is hot. It's either blue or actually slightly invisible in the ultraviolet area, and that is a hot flame. Now, the problem with carbon monoxide is that the lungs, let me just put in, the problem with carbon monoxide is that you have these 2 big bags inside you, your lungs. And what happens is that oxygen, blood collects oxygen, O2, and takes it to the muscles. And it also then it picks up carbon dioxide, which is being made in the muscles, and it takes it back to the lungs. So we breathe in, the oxygen is taken from the lungs, sent to the muscles. The carbon dioxide, which is being created in the lungs, is sent back to the lungs and got rid of. We breathe it out. The problem we have with carbon monoxide is that the thing inside the blood cell that connects to oxygen and connects to carbon dioxide to move them around is called hemoglobin. Now, carbon monoxide, if you get carbon monoxide, which is CO, if you get carbon monoxide into the blood cell can't let go of it. So if you have a blood cell that has carbon monoxide attached to it, that blood cell can never let go of the carbon monoxide. So it can't go to the muscles and change the carbon monoxide and get a carbon dioxide, and it can't go to the lungs and change the carbon monoxide and change it into an oxygen. Basically, if you get a blood cell that has carbon monoxide attached to it, that blood cell ceases to work. A red blood cell I'm talking about. That red blood cell just ceases to function. Now you've got an awful lot of red blood cells in your body. You've got about 8 liters of the stuff in your body. But if you give yourself enough carbon monoxide, you poison your blood. The more carbon monoxide you take in, the more you poison your blood. And the less blood, effectively, the less blood you have. Now, when you are unable to deliver blood to the muscles and to the brain, what starts to happen is the brain starts to slow down. The brain says, oh dear, I'm a bit tired now. And the brain slows down, and goes to sleep. And then you wake up and you're dead. Now that's a big problem for us because, you know, it kills you. It happens. There are problems in Australian houses with the small flueless heaters that you have, the small flueless gas heaters. Because those small flueless gas heaters, when they get old, they start to give out carbon monoxide. If they've not been properly maintained, flueless gas heaters give out carbon monoxide. Now that is a problem for us. It will make you tired. It will make you feel ill. It will give you a headache. It's a huge problem for small children because although we have 8 liters of blood, small children might only have 4 liters of blood. They can't afford to lose as much. They can't afford to have their blood poisoned. So if you have a flueless gas heater in your house and you have small children, you really shouldn't use it. So that's carbon monoxide, a very dangerous gas. Oh, going back. The next gas, nitrous dioxide, nitrogen dioxide. Now, nitrogen dioxide causes lung illnesses and can bring on asthma attacks. That's another thing that comes out from car exhausts and basic pollutants. Ozone. Ozone is O3. It's superoxygenated oxygen, if you like. Ozone is O3. You get ozone wherever you have high tension electricity or wherever you have sparks. Lots of electrical machines will create ozone. Ozone has been linked with lung disease, with heart disease, and basically it's been linked with a reduction in life. So ozone, there's been a lot of research that proves that ozone actually shortens your life. Sulfur dioxide, well, that's rotten egg smell. That can make you ill. Once again, heart disease, lung diseases, and can trigger asthma attacks. All of these gases we now monitor in buildings to try and get rid of this sick building syndrome. Luckily, there's a new technology available to us, which is called thick film technology. This uses a special type of plastic which will absorb these gases. And as the plastic absorbs these gases, its resistivity, its resistance changes. So if we lay very fine copper lines in the plastic, the resistance of those copper lines changes as the gas concentration goes up. So this thick film technology is allowing us to create air quality sensors, and we're finding them increasingly in buildings. In car parks, we use them to monitor the pollution level in car parks, to decide whether to turn the exhaust fans on or not. In airports, we use them to monitor the levels. The air quality level is monitored in customs halls in airports, because if it gets too smelly in an airport, the dogs can't smell the drugs. So the air quality is very carefully controlled in customs halls so that the dogs are happy. It doesn't matter how unhappy the people are. The only thing that matters is that the dogs are happy. So that's air quality. Any questions on that? Okay, we'll move on.